You're welcome back to my YouTube channel. This is Programmed Mathematics. I am Moses Oluwasegun Alex, and in this video I'll be explaining how to solve simultaneous equations, okay, using the matrix method, the matrix method. So now in this case here, in this video I'll be explaining simultaneous equations with two variables. Okay, so when we say simultaneous equation with two variables, okay, we simply mean there are two linear equations, okay, and then each one has two variables. All right, so how do we solve simultaneous equation using this matrix method? Okay, now in another separate video I'll be explaining what is called the Cramer's rule. The Cramer's rule also follows the same matrix method but pure application of determinant. But when the question says you follow the matrix method, you are not expected to use the Cramer's rule. So you see how that is done. Now, for example, let's take this as example number one. Okay, so we want to solve the equation. Solve the equation. Let's say I have 3x. Solve the equation simultaneously. Simultaneously. Okay, using matrix method, using matrix method, and the equation we have is 3x plus 2y. Okay, 3x plus 2y is equal to 7, and the 3x minus, let's say, let me switch this, 2x minus 3y is equal to minus 4. All right, so we have this equation to solve using the matrix method. Now, how do we solve this using matrix method? This is not Cramer's rule, matrix method. So in this case here, first thing we need to do is this whole equation is going to be transformed into a matrix. The whole thing we are seeing here, okay, is going to be transposed into a matrix. First, we form the matrix of the coefficients of x and y. We form the matrix of the variables. And then also, we form the matrix of the result we have after the equal to. But before you use your matrix method to solve any simultaneous equation problem, ensure that the variables are properly arranged. You have x under x, y under y. If you have more than one x in the equation, first, make sure you reduce the equation to just two variables, each equation having three terms. Okay, the first, second, the equal to. First, second, the one after the equal to, like that. All right, so we have the form here already. So first thing we need to do, write out the matrix of the coefficients. So solution now, matrix of the coefficient first, that's, we are solving the equation 3x plus 3y equals 7. And 2x minus 3y equals minus 4. So the matrix of the coefficients here for x, the coefficients of x are 3, 2. From the first and second equation, this is equation 1, equation 2. So for the first, the coefficient of x, we have 3 and 2. So write that out, 3, 2. Then for y, we are plus 2 minus 3, 2 minus 3. Okay, so this is x, this is y column. Now, the next one is the matrix of the variables. Just in the same order of appearance here, all right? X comes first, followed by y. So write your x as the first element, followed by y. Then this is equal to matrix of the result after the equal to. And so in this case, we have 7 minus 4. Okay, so this is what is referred to as the augmented matrix. We call this the augmented matrix. All right, so this equation you have here now has just been translated into this. Now look at it. If you multiply these two, 3 times x is 3x plus 2 times y, that is 2y, equals 7. That's the first equation. Then the second one is 2 times x, that is 2x, then plus minus 3 times y, that's minus 3y, and equal to minus 4. So what you are seeing here is still the same equation, but in the matrix form. Right, so once we have that, then how do we solve this using matrix method? Look at the way it's going to be done here. Let's take this matrix A, this matrix of the coefficients. Let's call it matrix A. Then the matrix of the variables. Let's call it matrix X, capital X. Okay, you can call it anything. Just call it X. Matrix of the results after the equation equal to, let's call this one B. So in this case, what we have is AX equals B. The matrix we want to find is this matrix X. Okay, this matrix X is what we want to find. If we are able to get this matrix X, we know what X is, then we know what Y is. Then the problem is solved. So how do we get this? Normal mathematical expression or equation, we demand that if we are to find the X from here, we divide both sides by A, which is not wrong. Yes, that's exactly what we are going to do. But in the case of a matrix, we do not divide by a matrix. Rather, we multiply by the inverse of the matrix. So in this case here, if we assume here now that we are going to multiply both sides here, okay, what you have here by inverse of A. So we are going to have inverse of matrix A times A, X, will be equal to inverse of matrix A multiplied by B. Now remember, I've told you in one of the videos, when you multiply a matrix by its the inverse of a matrix by itself, you multiply a matrix by its own inverse, or you multiply the inverse of a matrix by the matrix, what you have is an identity matrix. So in this case here, you have an identity matrix multiplying X equals A inverse times B. So in this case, when you multiply an identity matrix by another matrix, or a matrix by an identity matrix, what you get back is the matrix. So in this case, X is equal to A inverse of B. So all we are simply saying is, we find the inverse of matrix A, multiply by this. Whatever we get gives us the value of the matrix X. And from there, we know what X and Y will be. As simple as that. Okay, so I believe from here, you can find the inverse of this matrix, find it, then multiply that by the value of the matrix B here. So if we are going to do that for this matrix now, okay, so let's do that here. So look at this from here. So let me clean this. I don't need this one again. All right, so it means we're now going to have matrix X to be equal to inverse of matrix A. Since this one is a 2 by 2 matrix, let's go back to the formula. That'll be 1 over AD minus BC, then multiplied by D, A minus C minus B. And of course, the B itself is what we have here. So let's still leave out the B. We'll replace everything together at once. And so what does this mean? 3 times minus 3, that's 1 over 3 times minus 3 is minus 9, minus B times C. B times C, this one 4, 2 times 2 is 4. Bracket, we switch the position of 3 and minus 3. So minus 3 comes here, 3 down here. The 2 and 2 here will be multiplied by minus 1. So minus 2, that's for this. Then the matrix B itself is 7 minus 4. 7 minus 4. All right, so every other thing here is to simplify this and multiply out. So if we are to do that, this is 1 over minus 13, bracket, minus 3, minus 2, minus 2, 3, okay, 7 minus 4. All right, so let's multiply these two first, then we'll come back to the scalar here. Minus 1 over 13, bracket, minus 3 times 7, that's 21. So that's minus 21 plus minus 2 times minus 4, that is 8. So we have 8 here. Okay, then Minus 2 times 7, that's minus 14, plus 3 times minus 4 is minus 12. So minus 1 over 13, bracket, minus 21 plus 8. That is 8 minus 21. So this minus 13. Okay, then minus 14 plus minus 12. That will give us minus 26. So this is minus 26. Okay, so if we simplify this, what we simply have there is saying, okay, I still need this matrix for confirmation here. All right, so if we multiply this by this, minus 1 over 13 times minus 13, so that will give us 1. So this is 1. And of course, minus 1 over 13 times minus 26, that is minus 26 over minus 13, that is 2. So which means matrix X in this case is 1 and 2. So this is also the same as X comma Y, and that simply means X is equal to 1, Y is equal to 2. And you can confirm that. You know, when you solve simultaneous equation, you can't be sure if your answers are right or wrong, whether a teacher is there or not. Simply use a cross-checking method. The equation says 3x plus 2y is equal to 7, and 2x minus 3y is equal to minus 4. Right, that's the equation there. Okay, so if you bring in 1 for x, 1 here, 2 for y, 2 here, 3 times 1 is 3, 2 times 2 is 4, 3 plus 4 is 7. Then 1 here, 2 here, 2 times 1 is 2, 3 times 2 is 6, 2 minus 6 is minus 4. So which shows that what we have as the values of x and y are very correct. Okay, so this is how the matrix method is used in solving problems of simultaneous equation, especially 2 by 2 case. All right, so in the next video, I'll be explaining how to solve simultaneous equation using the matrix method, where we have 3 equations, 3 variables. That's simultaneous equations in 3 variables. Okay, so please, if this is your first time of coming in contact with this YouTube channel, this is Programmed Mathematics. I am Moses Oluwasegun Alex, the tutor on this YouTube channel. So please help me by liking the videos, give me thumbs up on the videos, give your comment in the comment section, at the same time recommend the videos to everyone around you. So please, in the next video, we shall be looking at solving simultaneous equation in 3 variables using matrix method. And after that, I will wrap it up with using the Cramer's rule. All right, so please, let's see in the next video.